Right. I want to do integration by parts a second time. Let's take my new integral, e to the x cosine of x dx. And now this is going to be equal to some u times v minus v du. I need to pick a u. I need to pick a dv. What I'm going to do, since I picked u equals the trig function last time, I'm going to do that again. U equals the trig function, and this time around that's the cosine of x. dv is going to be e to the x dx again, and the rest of my formulas here sort themselves out. They only look a little bit different from the last round. Let's fill out my recipe card. U times v is cosine of x, e to the power x. I subtract off the integral of v du minus sine of x dx. And there's my e to the x. All right, well, it looks like I just got back to where I started from. But let's see what happens when we take this formula and move it back up to the top. In round one, I said sine of x e to the x dx, take the integral of that, is equal to sine of x e to the power x minus a new integral, integral of e to the x cosine of x dx. In round two, I found a new way to write this integral. So the sine of x e to the power of x outside comes along for the ride. And now remember that I have to distribute this minus sign through whatever the formula of this integral is. What is the formula of this integral? Back in round two, I said that I have the cosine of x times e to the x minus the integral of minus sine of x. Okay, that's a lot of negatives there. So let's be a little bit meticulous when we work through this. I have sine of x, e to the x, negative cosine of x, e to the power x, all right? And for this integral, I'm going to pull that negative sign out. So I have minus, minus, minus an integral. Well, two wrongs don't make a right, but three negatives make a negative. So this will be integral. What have I forgotten to write here? I forgot that. Thank you. Minus the integral of the sine of x e to the power x dx. And then I'm going to carry this through on the left side as well. So just copy that. Well, hey, integral that I want, and some other stuff. So I am going to add this integral to both sides of my equation. And I'm totally allowed to do that. Algebra just says, as long as you're adding the same thing on both sides, we're good. On the left-hand side, I have twice the integral that I'm trying to find the solution of. On the right-hand side, I have a sine of x, an e to the power x, minus a cosine of x, e to the power x. And as a technicality, I need to have my constant of integration, because this side is an indefinite integral, this side is my antiderivative. So divide by 2, and I'm done.